In this video, we are going to learn how to solve systems without unique solutions. Now, I set up both of these examples at the top here to eliminate in one step. So you'll see here when I add these two equations together, the x's cancel and the y's cancel, giving me 0 is equal to 0. Now, this is very unique because I can't solve for any variables since there's no variables left. So when this question asks what are the solutions of the following systems, but then it says explain, this elimination gives an equation that's always true. What this means is that these two equations in the system represent the same line, meaning when I added them together, they canceled out because they are the same value. So almost like I subtracted them from one another. So this reveals that this is a dependent system with infinitely many solutions. So if you ever end up with a statement that is always true, that will be a system with infinitely many solutions. Now, if you use elimination and everything cancels out, but you end up with a statement that is not true, meaning always false, as in 0 is equal to 16 when I added these two together. Again, the 4x and the negative 4x canceled, the negative 6y and the 6y cancel, and the 6 plus 10 gave me 16, but 0 does not equal 16. Well, since that's always false, these are actually parallel lines that actually are offset from each other with a different y-intercept. So this is an inconsistent system with no solution. So if you ever get a false statement, that system has no solution. If you ever get a statement that's always true, your system has infinitely many solutions. But let's put this into practice. So again, what are the solutions of this system, and then explain what your solution means. So here I'm going to try to use elimination. I'm actually going to look at this first equation, and I'm going to multiply it by a positive 2, so I can get a negative 2x and a 2x, so the x's will cancel. So I'll have negative 2x plus 2y equals negative 4, and I'll keep the second equation exactly the same. And when I go to add these equations together, the x's will cancel and the y's will cancel, give me 0 is equal to negative 4 plus 0, negative 4. Now, since this statement's always false, there are no solutions to this equation. Now, I've shown you how to do this with elimination. Now let me show you that it still works even when you use substitution. Because as you can see here, I have a y that's standing by itself. So I could actually take 4x plus y equals 6, subtract 4x, and I get negative 4x plus 6 is equal to y. And I can substitute that into my other equation. So 12x plus 3 times negative 4x plus 6 is equal to 18. Distribute the 3, give me 12x minus 12x plus 18 is equal to 18. The 12x's cancel, and I'm left with 18 equals 18, which is always true. And you can even subtract 18 from each side or add any number you want to. It'll always be true, meaning this system of equations has infinitely many solutions. And one way you could represent your answer in this particular case is you can say, given any x, what should y equal? Well, y should equal negative 4x plus 6. So the ordered pair would be x comma negative 4x plus 6, because for this particular x, that's the particular y I want to find. And that's how you solve a system without unique solutions.